So this is pod 1. This is pod 1 that was actually installed about 18 months ago initially, with our initial requirements. It was designed to be around the 7 odd kilowatt of maximum load for the entire pod. So over time, as everyone knows, IT changes dramatically. So we learned a lot of lessons when we implemented pod 2. So with the actual pod system, there's a few concepts that work on. Number one is the no raised floor. Things like cleaning, for example, are a lot less grief when you don't have a raised floor to go under. Also the power and communications reticulation, that it also makes a lot more sense to run it overhead instead of the, running it under the floor, which can be difficult to do. There's also, of course, the OH&S implications that are part of the raised floor as well. So the way that the hot oil works, it's a hot oil containment system. So this pod is made up of different cabinets covering everything from storage, communications, compute. What happens is the air out here is a standardised temperature. Depends on what you want to make it. We've actually made it around 22 degrees. What happens then is that 22 degree air is brought in through the servers and the storage equipment, all the computer equipment into the aisle behind. The aisle behind is then the hot aisle. So the air in there is quite warm as opposed to out here where it's quite a pleasant room temperature at the moment. What happens then is the air cycles back through these air conditioners. So you've got a number of fans and cooling coils, chilled water cooling coils, which pull the air from the hot aisle, condition it to cool it down out into the general mass of air. The best advantage of that is in a traditional perimeter cooling, you're cooling it down to 14 or 15 degrees. Whereas here, we're not working the air anywhere near that hard. We're not cooling it anywhere near that level. As you can see, the power again is a modularised system. The best advantage of that power is all the power rails, all the PDUs in each cabinet come back to here and also another one in this row. So every cabinet has 2 power supplies, and in this case, one from here and one from up the other end of the pod. The same is replicated on the other side of the pod in the other row. The advantage of that is you don't have to worry about work safe, and it's also a switchboard in 300 millimetres wide by 42 RU high, as opposed to having work safe boards which take up a lot more space than that. Our fire suppression system is there. We actually use the micro mist type fire suppression system for only within the pods. The fire system is the suppression system is triggered by a Vestas setup. So when it detects it in that particular pod, it'll actually fire the micro mist, and what that does is it allows you to come back from a fire incident with a lot less downtime. So we'll just go into the hot aisle. And as we come through the hot aisle, you'll notice that it's actually a lot warmer in here without being excessively warm. And that, of course, depends on the load. Depends on how much load you want to put in there. As I said, this pod is averaging between 5 and 7 kilowatts per rack. So that varies, some are more, some are less. Depends on the actual purpose of the rack. You might also notice that we have staggered air conditioners. In some places we've got 1 air conditioner per rack. In others we have 1 air conditioner per 2 racks. What that allows us to do is have some cabinets which are high density and some which are lower density, for example network cabinets, which don't have the same requirements. So as we can also see the back of the air conditioners as we were looking at before. So saying the air comes into the back of the air conditioner from the hot aisle area, and what that allows you to do, that then makes sure that all the hot air comes through there and only cools down what is required. So this was our initial go at doing a pod. Over the time, from the design and even the implementation, within 6 months our requirements changed dramatically. We found some of the lessons that we learned is that 42 RU doesn't make the best idea of our footprint. The best example of this room is we're looking at this computer data center. It's a 500 kilowatt facility in a space of around 500 square meters, including the UPS. So what we'll do now is we'll go and have a look at the high density pod. So as you'll see in here, it's a lot of storage, a lot of pizza boxes with only a couple of blade servers. So this is our pod number 2. This is our second pod, and we implemented a lot of lessons that we learned when we did pod 1. Number 1 is the network. The network has changed dramatically. In this pod, we actually have no copper coming into this pod from the rest of the network. It's just not required with the switch setup that we have. Everything is run via MPOs into the top of the cabinet, and then this pod is all high density compute. So each rack has 4 blade chassis in it. So we have a row of these, and these blade chassis each blade chassis allows you to put 16 servers on each blade. So as you can imagine, they do start to put out a fair bit of heat. So these ones here put out an average of 15 to 16 kilowatt per rack at the moment. In there we also have local 10 gig switches and also local SAN switches and SAN directors. As you can see, as we do this more and more, we put more intensive computing, and it's likely to change again in the next couple of years. So again, it gives us the flexibility, the pod solution gives us the flexibility to manage how we do that going forward. So one of the things that we're asked to do, and one of the key drivers of high density, is computational clusters and high density computing. Here's an example of what we've done recently with one of the faculties, and it's total computational cluster. So what that means is it's a cluster of up to 6 blade chassis, all linked together, performing intense and complex calculations. The sort of thing that a few years ago would have been many, many years for simple computers. And now this sort of thing is what this data center is really built well for. For an example, this is over 22 kilowatt. This is over 22 kilowatt in one enclosure, in one cabinet. And when it's working full tilt, and that allows a lot of work to be done a lot more quicker, saving space because of the density of it, and also more efficient use of our resources. So what we might do is have a look at the UPS. Okay. Go from there. This UPS is a Symetra 500, Symetra Megawatt 500. So what it effectively does is that's the brains of the Symetra unit, UPS. You've actually got modular power. So each of these power modules is 25 kilowatt. So we have 20 of those. So you have a certain level of redundancy if you need to replace anything or change anything. So again, we've got very detailed information on the screen that tells us exactly what's going on in our computer room. Again, all modular, all in 42 RU cabinets. So everything is in row in a particular case. Because of the efficiency of this unit, it isn't in a hot aisle. It's not required. We actually have this in the general air conditioning of the room. So it works well. So again, it's got 2 cabinets of power modules, 1 cabinet of the main unit, and then 4 cabinets worth of batteries. At our current load, this will give us about 27 minutes of run time. Obviously about 15 minutes of run time when it's at full tilt. So very straightforward for the technicians to work on. Should any change or anything need to be done, it can be done live. Same goes for the batteries. With the batteries, these batteries are all modular, and again, they're smaller than your traditional batteries, so you minimise a lot of your OH&S risk. Not only that, is a lot of these batteries, they're computer controlled, so instead of having to, every time maintenance is done, having to climb into the battery cabinet, the UPS technician does it all from the control screen. This also tells me at any given time, should I have a battery issue come up down the track, I'll know about it straight away, and then we can raise a service call if required. Now what I might do is have a look at the chiller distribution units. So the way that the chilled water works is we have cooling units outside. We have our cooling units outside, two 500 redundant chilling units, and what actually happens is they pump chilled water into this manifold. This manifold then provides water, chilled water, out to the in-row cooling units. So again, you can see that you can do everything live without actually taking it offline. It's small footprint and modular, so it just makes it very simple when we need to expand. Already looking at expansion of this second pod due to extra operational requirements, and again, it's going to be very straightforward and it'll happen with no downtime. One of the best parts of the Schneider StructureWare data center software really is StructureWare Central. What it allows me to do is have really detailed information on what's happening inside my data center at any given time. The other really good things about it is that information is available anywhere. With the iPhone app, that means that I can be anywhere where I've got a 3G signal and be able to see any of this information in detail. So I know when I've got a problem, I know how important the problem is. It allows you to drill down, not just from the site level, from the data center level, and then even down to the rack and the PDU level. It really allows you to have some really detailed information at any given time. For example, and one of the other things I can do is with virtual devices, I can tell at any particular given time, if I put a few devices together, they can then work as a tag type system, which allows me to tell what's going on within a particular set of computers. A good example is the engineering cluster that we looked at, which is across a couple of cabinets in total. I'm actually able to have a look at the power used for over any given time of that particular set of computers. So you can see here, for example, it fluctuates between 27 and 28 kilowatts. And I can give that to the business owners. So of course the business owners can then tell how much power their cluster or their equipment is using at any given time. It also allows me to tell what, for example, things like my fluid temperature, my fluid entering temperature is, so I can really tell how efficient my data center is and whether it's working as it should. One of the other advantages is the surveillance packages. It also allows me very detailed, granular information and very simple way of pulling up video of any incidents. So from a security perspective, you can really see what's gone on. But not only that, is if I'm in a remote location and things aren't looking right, I can actually tell and inspect the security logs or have a look real time and see what's going on inside my computer room. So, again, simple things like that give me a lot of information that can be very handy when I'm trying to see whether I have a problem, or also for predicting growth over time. One of the examples of that, if I go to reports, a very simple report function. If I want to have a look at the UPS power over a given period of time, I can actually ask for that report to be done in a pre-saved report. It'll tell me what the report is over what the power usage is over that given time. And then I can actually get a trend. It'll automatically calculate a trend. So it'll tell me when I'm likely to run out of power or if my phases are out of balance.